in a while. Whatever. Okay, let's just review those three topics. First of all, the inverse trig functions. Amanda, how you doing?
I'm good.
Did you ever get all your questions in that email, that flaming email you sent me, that yelling at me and things?
The lab thing is not opening at all.
From WebAssign.
Yeah.
Yeah, yeah. So I sent
Not
you.
just from WebAssign.
What's
The email that you sent me, it didn't even open at all.
Okay, because you have to make sure it's on one.
I did.
Okay.
I'll show you.
Okay. When I'm done, we will go through this. And if worse comes to worse, I will send you the 6 labs. No, 4 labs.
Okay.
I'll just send it to you. But I want to see exactly what you did. Okay. Just surprised you didn't write it all in capital letters, your email. All right.
I know what the issue is.
Yeah, I do too. It's what everybody, the link comes as a break in the middle of it because of the length of the link, and people copy and paste it in there, but there's a break. There's a character 23 or 10, or it's a carriage return ASCII code that's stuck in the middle of it. You have to select it, copy this, and then copy this, and put it right next to it. So there's
and
no.
then erase the thing that is between it too. That's what I did. And then it did open, but it didn't download on my computer.
Oh.
It's not showing. It's just showing how much kilobyte it has. It's in storage in my computer or something like that. It doesn't show anything that's like numbers. I don't see calculus in it. I just see weird things.
You see what?
Weird things.
Weird things. Well, listen, Amanda, I can't, depending on what you did beforehand, I have no idea. All right, who's here? Levi. How you doing? Somebody else snuck in, too.
Actually, we walked together.
Oh, is that what happened? Oh, it was just me.
I think I did.
Oh, well, no, I got you're here. I thought there was 2 people who just came in.
Oh, I just went to the bathroom.
Oh, okay, Abby. All right, the inverse trig integrals. One of the things we did last time, we did this. The integral we had before was the integral of 1 over 1 plus u squared du, and that was inverse tangent u. Okay. This is an integral that we get right from Calc 1, because we have the derivative of the inverse tangent in Calc 1, which is 1 over 1 plus u squared. Well, what we did last time, we generalized this to this integral, 1 over a squared plus u squared, where the 1 doesn't have to be a 1 here. It can be any constant. We'll call a squared du. And that's 1 over a inverse tangent u over a plus c. So we generalized it to accommodate an a squared there. In other words, if you had this integral to do, you'd say, oh, that's 1 over a squared plus u squared. A squared is 49. A is 7. So it's 1/7 inverse tangent x over 7, u would be x here, plus c. And that would be the integral, and you're done. Okay. I also mentioned the possibility of not memorizing this generalized form, simply knowing this form, but being prepared to take this integral that's given and, in effect, derive this form by doing the following. Factoring out of 49, recognizing that what you now have is this, realizing that u could be equal to x over 7, du would be 1/7 dx, and we can get that. We can always get a constant, okay? Multiply by the constant 1/7, and compensate by also multiplying by 7. and ending up with this integral, 7 over 49. Okay, and we end up with the integral that we had originally, and that gives us an answer of 1/7 inverse tangent u, which is x over 7, plus c, which is exactly what the generalized form gave us. So, bottom line is this, okay? You memorize a slightly more general form with a squared plus u squared, in which case you can take this integral and do it in one step and get the answer. Or, say, forget it, I've already got too much to memorize. Just know the original and be prepared to take this new integral and, in effect, derive this form, okay, by taking that 49 out and ending up with this. So this is a few more steps, but it's a little easier memorization to make. It's your call, okay? So that was on the inverse tangent. We also did the inverse sine. We generalized the inverse sine. What we had before was 1 over the square root of 1 minus u squared du as inverse sine. And we generalized that to 1 over the square root of a squared minus u squared, which is inverse sine u over a plus c. Okay. The tangent has a 1 over a on the outside, and the inverse sine does not. Okay. Alrighty? And then we did the inverse secant. The integral we had before was 1 over absolute value of u square root of u squared minus a squared du is inverse secant. Oh, no, it's not. That's a lie. Okay? We had a 1 here. And then we generalized it to that I just wrote down. The integral of 1 over absolute value of u square root of u squared minus a squared du. Okay. Everybody all set on that? And that was equal to 1 over a inverse secant u over a plus c. Oh, rats. Alrighty? Well, I'm off. Oh, yeah, good call, good call. That's C. This thing here is a C. Okay. That's the more generalized form. Okay. Okay, that's one thing we did. Next thing we did. We okay with this? Next thing we did was to do cosh and cinch. Okay, we did cosh and cinch. Hyperbolic trig functions. Nope. Yep. Okay, the hyperbolic trig functions. Cinch, hyperbolic sine of x, e to the x minus e to the opposite of x over 2. Cosh, hyperbolic sine, hyperbolic cosine. And what we did the derivatives and integrals of each of these. We said that if y is equal to sinh u, the derivative is cosh u du dx. Derivative of sinh is cosh. If y is equal to cosh, the derivative is sinh. And we derived that. We used the definition here to do that. From these two derivative rules, we've got two integration rules. The integral of sinh is cosh, and the integral of cosh is sinh. Okay? You'll see on the sample test, there is something, there will be one of these on there, okay? You'll see what it's like, and it's very similar on the test that you'll see on Monday. Okay? Okay. All right, how's this look? Is this okay? Karen, you okay with this? Okay. Okay.
Okay, I'm good.
Okay. Carlos, you okay with this?
Could you just slide it just a bit more over? Just can't see the top right hand.
Oh, yeah, that's right. There. Okay. Yes?
In this case, it doesn't happen, for example, the inverse cosine is negative sine.
No. No, it's interesting. They're called hyperbolic trig functions because of the numerous properties that are similar to trig properties. But some of the trig properties are the same. These are the same as some of the trig properties, but some of them also are different by a sign, plus or minus, and that's what happens here. The integral of sinh is cosh. The integral of sine is a negative cosine, but the integral of cosh is sinh, and the integral of cosine is sine. So on one hand they are the same, but the other one's off. Okay, so okay, how are we doing? Okay. The last thing we did two applications of the integral. We did population growth and radioactive decay. Population growth. Okay, population growth. Let me see if I can, okay. We started with this differential equation, dp dt. Is Kp. What this means is the rate of increase of the population with respect to time is proportional to the population at any given time. This is exponential growth. Population's increasing at 10%, 5% of the population, okay? At t equals 0, we said the population was p sub naught. We solved the differential equation by isolating the variables and integrating each side. And we obtained this equation for the population growth. Okay. This is an exponential model for population growth. Basically, it says that the organism increases, and the population of that organism increases exponentially over time, which is okay for a short period of time, but it's never okay for an extended period of time. No organism can increase at an exponential rate over an extended period of time, okay? So it's a simple model. It works over a real constricted time and other controlled environments, but it's not the one that's used in real life. But it can be used in certain cases. We did an example of strep throat with streptococcus bacteria in your throat, and it's increasing exponentially over a short period of time.
What is P equal?
What's that?
P.
P is the population at any given time. P sub naught is the initial population. See, an example of the strep throat thing would probably be Lewis, who just came in here with probably strep throat. He's just gonna. No. How you doing? You okay? Somebody said you were near death the other day, but no, you're.
Last week.
That was last week?
It was too cold.
Oh.
It caught me really bad.
All right. Okay, you're better though?
Yes, I still came to class, so.
I noticed that. I noticed. You're a trooper. All right. Good deal. All I've done so far is to repeat what I did on Tuesday. Okay? So we got this for population growth. A typical problem, you'll see it on the test that I pass out, would be a typical population growth problem that you see on the test on Monday. You know, I'll give you the initial population, I'll give you the rate of increase, and ask for how long it takes to double that population. Okay, and we'll do that out today. The other thing we did was radioactive decay. The radioactive decay model, on the other hand, works extremely well over an extended period of time. Basically, it starts with the fact that the rate of decrease of the radioactive material is proportional to the amount of radioactive material that's present. So we have a negative K here, okay, because this is decreasing over time. U-238 or radioactive iodine or radioactive carbon-14 or something like that. And again, at T equals 0, we're saying that amount of radioactive material is the initial amount.
You're running off the page.
I'm running out. Okay, good deal. All right, thanks, Jacob. And from this, we solved the differential equation and ended up with a very similar equation from before, except it's a minus KT up there. And this radioactive decay model goes like this. Radioactive material decreases over time. Okay? That's what we did the other day. Okay? How are we doing on that? Okay? All right, good deal. All righty. So, any questions on anything? Any questions, any homework? Anything? Yes?
Not directly on the quiz, but the person asked, do we offer Calc 3 over the summer?
As a distance course.
Oh,
Online only. I used to have it as a lecture course in the 90s, but we had like 2 or 3 people, and that's when I decided to create the first distance course here at SDCC, which was my Calc 3 course, 1996 or 5 or something like that. I know it. But it's offered as a distance course. Yes?
This is going to be on the test, right?
Population growth or radioactive decay, one of those problems will be on the test. Any other questions at all? Yes?
What's K stand for here?
It's a constant. It's like 10%, population growth of 10%. If something is increasing at a rate of 10% per hour, okay, that's what it stands for. It's some constant. Sometimes you'll be given the constant. Sometimes you have to solve for the constant. That's what we had to do in the radioactive decay problem. We knew the amount of radioactive carbon-14 at the beginning. We knew how much was there after so many years, and we had to solve for K. Once we solved for K, we could solve the problem to find half-life. That's what we did. But K is a constant, the rate of increase or decrease, depending on what problem you're doing.
So it's basically percentage, right?
Yes, exactly.
Yeah, thank you.
Karen?
I hate to ask a question about one of the derivatives questions on the homework, but I don't know what I was doing wrong.
Listen, questions are fine. If you don't know what you're doing wrong, ask a question. That's.
Okay, I was like, this is gotta be easy, but I don't know what I was doing.
Go ahead. Let's do the question.
So y equals 7x cosine h of x.
Plus, pardon?
7x cosine h of x.
Oh, cosh x.
Cosh, okay, sorry.
7x cosh x, yeah.
Minus 7 sinh x.
Like that. And find the derivative?
Yeah.
Wow. This is a weird old question.
Well,
Well, let's do it. It's a strange old question here. Okay, let's find the derivative. On your test, you'll see that there are no derivative problems, so consequently, this would not appear on the test. But there will be an integral for sinh or cosh on the test, okay? I'm pretty sure that's true. All right, we got a product rule here. So it's first times the derivative of the second. Derivative of cosh is sinh, plus second times the derivative of the first, okay, minus the derivative of sinh is cosh. Oh, this is kind of cool. Those nicely cancel out. You should have an answer of 7x sinh x.
Great, must have just been putting it in wrong then. Thank you.
I'm not sure how they want you to enter sinh or cosh. Maybe parentheses around the x. I'm not really sure. Carolina, how you doing?
Good, how are you?
Good. I don't know what to tell you. If in WebAssign you put something in, bless you, that you know is right and it's marking you wrong, try some alternative form. If you're still convinced that what you have is right, just send me an email and say, Burns, what I have is right. WebAssign is marking it wrong, change my score. Is it okay now? Did you just put it in?
No, no.
Oh, you're emailing your boyfriend or something. Oh, all right,
No,
that's
no,
okay.
I'm sorry.
Oh, that's okay. I thought you were putting the thing in there and checking it out. All right, no, that's all right.
Can you pull up the sign up on your phone?
Yes.
Oh, cool, okay.
I don't know if I can
People
reckon.
do it,
Oh,
so
cool.
I'd assume you can.
Yeah,
If they're doing some black magic or something.
I don't know. I think it can be done. Yes.
So, what's the integral of cos x?
The integral of cosh x is sinh x.
So doesn't that make it's the same thing either way?
Integral of sinh is cosh. Integral of cosh is sinh.
Yes. And
Yes.
the derivative of cosh is x.
Yes. And the derivative of sinh is cosh. The integrals and derivatives are the same.
In
Is what you're saying.
manner does the terminology matter?
Well, you have to say it's sinh and cosh. You can't say it's just.
Because if I ask you for the derivative and the integral, you're going to get the same answer.
Yes, that's true. That's true. The only that's pretty interesting. The only problem with that is, Jacob, if you have y equals sinh 7x, the derivative is sinh 7x times 7. The integral is not, because u would be 7x, d would be 7dx, and you have to multiply by 1/7. The integral would be 1/7. Oh, I did this wrong. This is cosh here.
You can't see.
It's a good thing because I screwed it up. Oh, okay. Hey, Chris. The derivative of sinh 7x is cosh, that little mess there is cosh 7x times 7.
Okay.
But the integral of sinh 7x, you have to multiply by 7 and by 1/7, is 1/7 cosh 7x. So in that sense, it would be different. Okay.
Is this 5.8?
I don't know. It's inverse trig functions.
Yeah, that's about it.
5/8. Okay. Ready? How are we doing? Any other questions? Caroline, what I've done, I went over the 3 topics that we did on Tuesday, and then I'm taking any questions, and I'm soon to pass out like a sample exam. You guys will work on it. Then I will go over it. And then I will show you the lab. The lab. Mathematical lab.
Friday?
What's that?
Is that due tomorrow?
No. Let's do a week from tomorrow at midnight.
Oh,
Okay?
next Friday. Next Thursday.
Friday.
Friday.
All right. Any other questions at all? That was a half a question? No? Okay. All right. I'm going to pass this out. I want you to work on it for 20 or 25 minutes. Here's the thing. It's going to record empty space for about 20 minutes. That's not good. So I should probably just stop the recording, but then start it up again. But that will be a second movie. That'll be...
He should be able to put them together.
You should be able to splice them together. So I should shut it off, though, is what you're saying, you think?
Yeah. I mean, if worst comes worst, we'll make 2 videos, but that's not...
Yeah, okay. All right, I'm going to shut this off.